Syntax diagrams. Yes, some excited faces. Just wait for it. So this presentation exists because I somehow volunteered to go over the text of the syntax diagram domain and the data specification, and I committed to it before taking a look at it. I should have done that. I should have done that. So I just want to share my sentiments about doing that and what came out of that. So actually, it's your last chance to opt out of this because I'm convinced you don't want to hear this. So please, go ahead, extend your coffee tea break instead. grab something to eat, have another coffee or tea, and eat those. So this is your chance. If you don't, then we go into the topic, maybe with an introduction for mere mortals. So what you see here is a syntax tree. So we start with natural languages, what we do every day, every second when we communicate. When we form a sentence in some language, even if it's a sign language, then we stick to some rules. These rules are implied by a grammar. And what you see here is what Noam Chomsky came up with in the 50s when he invented the paradigm of phrase structure grammar. So this is a syntax tree of a sentence in English, and it starts with a breakup. So you see all the past trees in terms of, there is a sentence which is composed of a noun phrase and a verb phrase, and this is then further parsed into noun phrases like an intermeter and an adjective phrase and so on and so forth. A verb phrase is somewhat more complicated, being parsed into a verb, another noun phrase, and a prepositional phrase to kind of indicate where the action takes place. So the brown dog chases the cat in the forest. And what you see is that you have some certain grammatical categories all listed here on the left side, and then these lexical entries at the bottom. So that is a very simple example in English. You may have seen this, especially if you have stumbled into any linguistics class or so. Of course, if you have another language, you have another grammar. So if we take the same sentence in Finnish, then it looks quite differently. And I have to apologize for the linguistic analysis because that's my own one. I'm probably treading on very thin ice here, much thinner than outside. So if we take the same sentence in Finnish, so ruskia koira jahtaa kissa metsässä. So hopefully you can understand this even as a native speaker. So it looks differently because when you look at the syntax tree, Finnish doesn't have any articles. So we don't need that. Whether or not you would use a definite or an indefinite article in the translation, then that depends entirely on the context. So for that, there is a different grammar in play also with the prepositional phrase, which is gone. So the location is marked directly as an affix on the noun. So metsä is forest, and metsässä means in the forest. But inessive is kind of being inside. And I won't go into the details of the partitive of kissa because that is hard to tell for people who think that this could be an accusative. It is not far from it. So Finnish is a wonderful language, by the way. I mean it. It has some nice features. So, of course, that was the whole point. Different language, different grammar. And let's get back to the English one, because I am a bit more familiar with that one. So, to put it a bit more formally, there were two folks also in the 50s who came up with something that we can see here, John Backus and Peter Naur. And they put some formalism into it and said, yeah, we have basically a pass tree that is featured by some start symbol. Here it is S for sentence, a number of non-terminal symbols, which means that they can be rewritten as something else and it's not a lexical entry, and some terminal symbols, these tokens down below, which constitute lexical entries. And these are then the rules as a set of production, and meaning, yeah, you can have a noun phrase, and that could be rewritten as a determiner and an adjective phrase, or you could have a noun phrase which is rewritten as a determiner and a noun and a single noun. So that is the kind of formalism that these two came up when they started about specifying the programming language Algol 60, which is quite some time ago. So that's that. And now we turn to rather more formal languages. And what you see here is the most basic expression in xQuery, namely a flower expression. What you see here is not the Bacchus now form, but an extended version of it. The extended Bacchus now form, simply called eBNF. And I think Niklas Witt introduced this in the 70s. And he came up with some concepts that we are now all familiar with, like repetitiveness, options, optionality, and groupings. And so this is something that you can see already in here. Is much simpler than what you have seen just before. And what we have in the Termino XML server documentation, and Software AG is their complete implementation of xQuery. And for that, there is also a grammar being used. And that grammar is written in eBNF. And from this form of eBNF, there is, by the guy who wrote the original parser for xQuery, also a railroad diagrams generator, by which you can go ahead and take an eBNF and come up with something like this, where you can see that this is indeed what the eBNF formalizes. So you have now the choice between the for clause and the let clause, but it must be at least once, must be one of these constructs. Then you have or have not an where clause, an optional order by clause, then the literal return, and any form of expression. So that's a nice way to put it, and readers can easily understand that. Well, that railroad diagram generator is still around. It's on GitHub, so it's also still maintained. Although Gunter Adamra no longer is with the company, retired. But what you cannot do, what I learned when I was involved back at that time as a technical writer, is that you cannot just go ahead and take that bunch of eBNF rules and say, yeah, come on, let's set up a process, and whatever you got in your software to produce the parser from, then let's take that and put it directly into the documentation. That won't fly, because the eBNF that is being taken for the software itself, that looks quite different from what you can see here. This is the reader-friendly version, but the other one is kind of optimized for the software itself. So it looks differently because the paramount interest here is to get maximum and optimum performance. So that's that. There are other forms that syntax diagrams could look like. One of them we find also in Software AG documentation. This is an example from the natural language, which has been composed and introduced in the late 70s, early 80s to complement mainframe database systems. And that may remind some people on command line utilities. If you look up traditional Unix man pages, then you see all the brackets and braces and stuff, and you know, okay, these are optional, these are not. So that is something that looks familiar to most of the readers of the target group, I would say. And they are familiar with that and they love it. And the only who love not, the only ones who love it, don't love it, is those who have to maintain it. Because what it looks like is this one. So this tiny little box is that tiny little code of HTML. It's a table. We use a full CALS table model in our in-ground house domestic XML dialect. And that is something that people certainly don't want to mess around with too much, too often. So not exactly what we want to do. But it's here, and I know that a colleague of mine wanted to get that table hell out of the door and instead come up with some eBNF and take that railroad diagram generator instead. That doesn't work because he had competence, he had perseverance, and he tried to convince the developers to go that route. But it turned out that some of the developers couldn't follow him because he was more competent in eBNF than those, and that led to some awkward discussions, I guess. So in the end, he failed and retired. But we'll see about that, what happens with that after all. Okay, so going to DITA. How can we represent syntax in DITA? We can ask the question, do we want any semantics in DITA, in our syntax markup? Or do you want a representation that is as close as possible to the actual grammar structure? Or do we want to have any shiny graphics from that? How do we do that? And we know we have got a code block, but we have also a dedicated syntax diagram domain, and that we could also take. Okay, these are the elements in the syntax diagram domain, and we can now spend the rest of the day to discuss each of these elements in painstaking detail. Maybe we don't. Jano has ordered a table, I guess. So let's stick to a very simple example. This is the way command line interface, the way that an internal command of ours is working. It's a kind of a wrapper around DITA-OT and a commercial solution, WebWorks publisher, that we use for production purposes. We use the DITA-OT for draft purposes, and that is kind of an abstraction on it. So that simple command just has some options, and you make a choice between a DITA map and some form of special project files. And that is what you get when you use bare bones code block, of course. It's readable, but it doesn't make a difference to the reader. It's just a line of code. And I also spread a lot of white space across the page now in order to make it a bit more readable. That, of course, you can at least enhance a little bit and put some DITA constructs around it, like command name, option, or parameter name, to add some semantics in here. Or you could go ahead and use a syntax phrase, synth element, and that is taken from the syntax domain, syntax diagram domain. And there you can see that here you have different elements, as I just shown in the table, and you have seen all the elements and memorized them already, so you know KWD stands for keyword, and there is a variable. Yeah, so these are already three different ways of trying to come up with something in DITA. Or you could go all in and use the syntax diagram element. And then you can, in some, to some extraordinary detail, go ahead and try to formalize the kind of structure that you have. So you have groups that you can have in a sequential order, group sec, or you have a group choice You can also mark whether these are optional or required elements. And then you can further down go ahead and take every single bit that you can see inside the syntax diagram and mark it semantically like this. So that's fairly straightforward, isn't it? Remember, that is what we wanted to represent here. And that's the rendering. So on the left side, you see the output of HTML5 as taken it directly from the DITA-OT toolkit. And on the left side, you see the output taken from, so there is one DITA-OT plugin in this presentation from Robert, a plugin that was originally, I think, written by Deborah Pickett. Well, it was not one plugin, it was a very large set of plugins, which has been thankfully reduced by Robert to a manageable set of plugins, but it simply worked. So what you can see here is an output that very much looks like what you would expect, only that for synth, even here is that syntax diagram, no, code block and synth, that means that all the delimiters, the braces and pipe symbols and brackets and so on, this is something that you put in yourself. If you use a syntax diagram, these are put in by the DITA-OT toolkit. So, because you have described it semantically, and then DITA-OT toolkit does what it does because of the semantic meaning of these elements from the syntax diagram domain. On the right, you see the same, only with the use of that syntax diagram plugin. So you get some sort of a railroad diagram, and not with so many colors, but with exactly the same way of organizing it graphically. And you can even put footnotes into this. How cool is that? In a syntax diagram. I don't know where that requirement came from, but maybe you could tell. So this is what you can get from DITA. But if you're really into it, DITA is about reuse. We all know that. And if you want to come up with something like, okay, we do syntax diagrams maybe for a whole programming language, then not calling only for trouble, but then you have to think about some concepts, how to do that in a somewhat efficient way. And then there is the desire to group certain elements and to reuse them as far as possible. So one element that you have is fragment. You can group a number of elements and define them as a fragment, and you can reference that fragment later on, but only within the same syntax diagram. If you want to get out of this, then you have to use something like symblock or syntax block. That is something that you can define and store it in an external file, and here for edit is here, so I use a key. So we have symblock reference to some syntax block in an external file, and so you can build up a library of syntax element groups, and that you can then pick from if so needed. So that's the way that you can do syntax diagrams in DITA. What this then looks like is you got the logging options which have been pulled from another file, so you get the expected output as you would with any text that is referenced from somewhere else. That is the conclusion that Simon Bate from Scriptorium made about 10 years ago. I would want to use any of it, with any of it referred to, should I use simple code block, should I use syntax phrase, or should I use the full-blown syntax diagrams? Well, my take on this is that one. Purism or pragmatism. You can go ahead and say, I'm interested in a semantic markup as much as possible. Then go ahead, try it out, see how far it takes you. Or you could say, well, I got that bunch of EBNF files. Why not take that? I'll take that railroad diagram generated. It's on GitHub. And then we get some decent graphics, and whatever you do, I'm fine as long as I get from your side, from the developers, any EBNF files. So the choice is on you. And that is what I have to tell you about my voyage, my journey with syntax diagram, domain, and DITA. Any questions or remarks from Robert?
One of those, not a question, but a comment. I do want to say, the slide said this is Robert's plugin. Deborah should get credit for this. She originally published this function as part of a set of about 50 plugins. We didn't need to use all of those, but this part was awesome. She took some of IBM's most complicated syntax diagrams and made the logic work. The updates I made were to take her plugins, which were written for, I think, DITA-OT 1.4, and bring them up to date so that they work with more recent toolkits, and then just separate out this function. So there are a few fixes in there, but most of it was just that. She did the hard work. So that's all.
Yeah, and I tested it using DITA-OT 3.7.4, and it worked like a charm. Just plug and play. I knew that the number of comments and questions would be fairly minimal, but there is one. One more. Yeah.
Yeah. When I was looking at last night an update on the different kinds of plant UML diagrams that are supported, some of them are UML, some of them are not UML, but one of them I noticed was a regex diagrammer, which has a lot of optionality and so forth. So that's what this is making me think of too, is there are these other formats where you express them in this other textual notation, and it can wind up, generating these diagrams. So that's one thing I wish I had for some really complicated regex expressions that someone else wrote. It's like looking at Perl, especially if it's hundreds of characters long, and you wind up copying and pasting it into regex 101 website or something, and it breaks it down for you. But it's I don't know. This is interesting to me because I think I asked ChatGPT to take an eBNF. Oh, it was the model in Oxygen's model view, right? Is it eBNF? Okay, something else, right? So I tried to do some kind of multi-shot examples of taking it, and then can you generate a plant UML diagram from it? And it did a few things, but it was mostly hallucinating. But it's I don't know, it's interesting. So what wound up happening? What was the end result for you at the company?
Well, I could tell you what the end result is for the specification, so that went through. But for the company, that is yet undecided. That is, currently we have many other things to do, and when it comes to the point that the legacy documentation is being converted to DITA, then we think about it much harder than that. But because of that table head, that is really, really wrecking people.
Yeah.
Thank you.